Hello everyone. On this second video, I want to talk about another law. It helps you to solve triangle. The name of the law is called Law of Cosine. And most of the time you use Law of Cosine when you have the case a sine, angle, sine. It means that you have two sides and you have an angle in between. However, you can use the Law of Cosine as long as you have enough information. As long as you have enough condition. Sometimes you have to use the law of sine first, then the second step you can use the law of cosine. Well, when you're doing math, you have to be flexible, okay? But if the question is in the case sine, angle, sine initially, then you can apply law of cosine right away, okay? And the law of cosine states that. So I put the law of cosine. Given any arbitrary triangle, okay, any arbitrary triangle, and I call this angle alpha, this angle beta, and this is gamma, and I call this is A, this is B, and this is C. So the law of cosine say that A squared equal to B squared plus C squared, you know, it looks like a Pythagorean theorem, right? But it's not. Minus 2BC cosine alpha. Okay? So the alpha over here and the A over here, the side A is actually the opposite side of angle alpha. Okay, it's opposite side of angle alpha. Okay, and similarly, we can do the same for B and C. So B squared equal to A squared plus C squared. Okay, minus 2AC cosine beta. So B and beta is opposite to each other, right? Well, actually, I was not wrong when I say that. It looked like Pythagorean theorem because you see, look at it. If cosine, if alpha is 90 degree, right? Cosine of 90 degree. Cosine of 90 degree give you what? Give you 0, right? Gives you 0. So that's why you have A squared plus B squared. A squared equal to B squared plus C squared. It's like a right triangle. So this is like Pythagorean theorem. Same thing over here. But that is for the case when the angle alpha, beta, or gamma is 90 degree. Okay, similarly, I can get C squared equal to A squared plus B squared minus 2AB cosine gamma. Okay, so gamma and C is opposite to each other. Okay, and you see that if a gamma is 90 degree, right? Cosine 90 degree is 0, so you have C squared equal to A squared plus B squared. It's kind of like a right triangle. Okay, this is kind of like a Pythagorean theorem over here. Okay, so I say that as long as you know the angle, okay, and you know the side that adjacent to that angle. Okay, so you see the angle alpha over here, for example. You look at the first formula, right? You see the angle alpha is between B and C. As long as you know B, you know C, and you know alpha in between, then you can find the opposite side. Okay, so you must have in the triangle, when you solve triangle, you must go for look at the triangle, look at all the information and determine if they have enough information, enough condition for you to apply law of sine or law of cosine or not. Okay. If you have enough information, sometimes you can apply law of sine right away. Sometimes you can apply law of cosine right away. Okay. But law of cosine most of the time they use for remark. Okay. Using law of cosine in sine angle sine condition, sine angle sine case. Okay, I mean you have two sides. And you have an angle in between. Then you can do the law of cosine. Okay. All right. Let's take a look at the example. Okay. I have arbitrary triangle. Kind of scaling triangle, something like this. Okay. And I say that this is 13.9 meter. Okay, 13.9. And I also have this is 34 degree 20 minutes. Okay, and this is 10 meter. Okay, and this is alpha. This is gamma. This is B. This is gamma, and this is alpha. Okay, and the question is, solve this triangle. Okay, solution. Okay. So I'm going to solve this triangle. And we want to see if we have, if we can use the law of cosine right away or not. Or we can use the law of sine. Okay, and we can use the law of sine. Well, the law of sine, when you have angle, sine angle, right? Or you have sine angle. And you have sine angle, then you have to consider how many triangle they have, right? By calculate the altitude, remember in the previous video. Okay, but let's see we can apply the law of sine or law of cosine right away or not. Okay, or sometimes we can use law of sine first, sometimes we can use law of cosine first. Depends on the situation here. Depends on what they're giving you. So over here they give you a sine and an angle in between, and another sine. Ooh, look at that! An sine, an angle, and another sine, and an angle here in between these two sides. That look like we can use the law of cosine, huh? We can use the law of cosine. And actually, in this case, you can use the law of sine too. I mean, the law of sine work. Okay, the law of sine work because you see that it's not in the case sine angle. It's not in the case sine angle. Then you don't have to consider the altitude, so that you don't have to see how many triangles they have. Okay, but because we're learning law of cosine, then just let's use law of cosine because in the case sine angle sine. Okay, but in this problem you can use law of sine too. Okay, but before we can use a law of cosine, I want to convert this to degrees. So 34 degree, 20 minutes will be 34 degree plus 20 minutes divided by 60, right? And what do I give you? Let me see. We have 20 divided by 60 is 1/3, right? So you have 1 divided by 3, right? Plus 30. So we have 30.33 degree. Okay. Then I can apply the law of cosine. So I can I already have the angle here. I can find the opposite side of the angle. So we're gonna have v squared equal to a squared plus c squared minus 2ac, right? Cosine of 34 degree 20 minutes means cosine of 30 degree. Oh, 34. I'm sorry. So it's 34. So it's 34 degree and 34.33 degree. Okay. And we already have A. A is the side opposite alpha. Okay, so 13.9 square plus, we already have C is the side opposite gamma, which is 10 square, minus 2, 13.9, 10, cosine 34.33 degree. Okay, go ahead, put it in. Go ahead, put it in. Let's see. And as long as you put it in and you take square root, because you need to get b, right? So b is square root of the whole thing. Okay, square root of that one, which is give you what? I'm not going to write it, okay? So I just go ahead and put it over here. So I have 13.9 square, right? Plus 100, right? Minus 2 times 13.9 times 10, okay, times cosine 34.33 angle, okay, give you 63.63. So then you take square root, you have 7.98. So 7.98 meter, and over here is I just need to write where is draw sort of radical symbols. They give you 63.63. Okay, so I got B. Okay, then now I can apply the law of sine. It's easier. So law of sine say what? I already got B over here, right? So I can say alpha, sine alpha over 13.9 equals sine of 34.33 degree over B, right? 7.98, right? Okay, equal to sine of gamma over 10, right? Then from this law of sine, and this apply law of sine, so I'm going to write over here, law of sine. So you can use the law of sine, you can use the law of cosine, it doesn't matter. But only the case when you have sine-sine angle. Sine-sine angle you have to consider, and you have to apply the law of sine. Okay, for sine-sine angle you have to apply law of sine. You cannot use law of cosine at the beginning, no way. Okay, and you have to consider h, the amplitude. So over here you can we already learned this. We want to solve for the proportion, right? So what we have? We have sine of alpha 7.98 sine alpha equal to 13.9 sine of 34.33 degree. Right, and then I can get sine of alpha equal to what? Let us see. You put the whole thing over there, right? 13.9 times sine of 34.33 degree, right? Then divide by then you divide by 7.98, right? So you should have let me see, let's do one more time, okay? Let's check one more time. 34.33 sine, right? Times 13.9 divided by 7.98. Give you 0.9823. Okay, you take x sine of this, give you alpha is 79.2 degree. Okay. So from here you can get gamma easily by take 180 minus alpha minus minus beta. So this is beta right here. However, you have to be careful over here because according to our picture, the question they already give you the picture, alpha over here is an obtuse angle, but we have 79.2, which is an acute angle. So it's not 79.2 because when you solve this equation, sine alpha 1.98223, this is positive, so the sine positive is the first quadrant and the second quadrant. This is the first quadrant. Okay, so we're not going to take it because the question is alpha is obtuse angle. So in order to get the second quadrant, your alpha is not 79.2, but it is you take 180 minus that. So your alpha is your alpha could be 180 minus 79.2, which is 100.79 degree. So you have to use this one. You have to use this alpha because it's corresponding to the question. Alpha is an obtuse angle. It's more than 90 degree here. So from here I can get gamma is 180 minus 107.8 minus 34.33 degree, which is give you what? Minus 34.33, 180, right? Minus 100.78 minus 34.33 give you 45 degree. Almost 45 degree. And here you go, we're done. So you have to be careful over here, okay? Because sometimes the question they just give you the number, and when you draw the triangle, you have to draw carefully. You have to try to be in scale as much as you can so that you can see the angle is obtuse angle or acute angle, because when you take inverse sine, it always gives you two conditions. Remember, when you solve equations, trigonometry equation, you have to consider the quadrant, right? And you always have to refer to the first quadrant. Then if it's positive or negative, then you refer to the first, the second one, or the third one, or sometimes the fourth one. Okay. So that will be all for this example. Example number 1. You can also find gamma using this proportion here, law of sine. And again, you have to be careful also, okay? Because when you take inverse sine, you have to be careful. One give you greater than 90, one is give you less than 90. And remember, gamma here is always less than 90. So you have to use you have to take the one that's less than 90 degree, okay? The law of cosine can be also used when you had a case sine. It means the question give you all three sine. Okay, then I asked you to find all the angle. So in the remark area here, I will add a little bit. So it's be sine, sine angle sine, and sine case. Okay. So let me erase example 1 so that I have enough space to do another example where you have sine. Okay. So actually, when you solve triangle, it's not really that bad. You know, all you have to do is you memorize the formula. You have to consider if it is corresponding to the question they give you or not. Because when you find the inverse, you have to be careful with that. Okay. Let me erase this too. For the case sine, our job is to find the angle, all three angles. For example, I have something like this. Example number 2. I have the triangle that look like this. This is not right triangle, okay? It's not right triangle. And I said this is 21.2 meter. This is 24.6 meter. And this is 12 meter. So when you draw a triangle, you have to be careful also, because you see that this side is 12, so I draw it kind of smaller than 21, right? And it's this 21 kind of smaller than 24. If you draw 12, that is bigger, longer than 21, then your answer, you may be very confused later, because the angle may be different, okay? And you don't know, you should take the obtuse angle or acute angle when you take the inverse of sine or inverse of cosine. So you have to be careful over there too, okay? So this is not a right triangle, okay? So this is beta, it's beta, this is alpha, and this is gamma. Okay. So you see in this problem, they give you all three sides already, and they ask you to solve this triangle. Okay, they give you all three sides. Okay. We have to scan. Let's say we can work with law of sine. Not, no, of course not, right? Because you see that in order to find law of sine, you have to know the angle. In order to use law of sine, we have to know the angle. Over here, we don't know any angle, so we don't know any angle. So we have to use law of cosine, because with the law of cosine, we can find one of the angle. Okay, so I want to get angle alpha first. So alpha is going to be a square, right? A square equal to b squared plus c squared minus 2bc cosine alpha. A is the side of opposite alpha, so alpha over here. Opposite alpha is 21.2 square. B is opposite beta, should be 24.6 square. C is opposite gamma, 12 square minus BC, 24.6 times 12 times cosine alpha. Okay. So I can get cosine alpha will be 21.2 square minus, right? 24.6 square minus 12 square, right? Okay. Divide by, let me see, divide by negative 24.6 times 12. Okay. And you put everything over there. Let me see what we have here. Let me put everything here. So I will have 21.2 square, right? Minus the 24.6 square minus 12 square, right? Divided by 24.6 times 12, close. Give you a positive 1.01. Oh, I think I missed number 2. Sorry. So let me redo it again. Divide another 2. Give you 0.507. Okay. And you take inverse of cosine. So alpha will be inverse of cosine. 0.507 inverse of cosine. Give you 59.5. 59.5 degree. Okay, and you see that this cosine over here is a positive, right? Cosine positive first angle at first quadrant and the fourth quadrant. So the fourth quadrant is 2 pi, so with 360 minus 360 give you 300.46, right? And which one you're going to take? Of course you're going to take the first one, right? Because alpha must be an acute angle, so you're going to take this one. Okay, you're not going to take 300 because it's not 300 here. Okay, so that's alpha, and now you know alpha 1 angle already. You can apply the law of sine. sine. So will be what? Will be alpha already here. So it will be sine alpha. Sine alpha is 59.5 over 21.2 over sine beta over 24.6, right? Equals to sine gamma over 21.2. So you have two proportions. I can find beta, and you take gamma. You find gamma by subtract from 180. So let me solve this first proportion here. So I have sine beta equal to 24.6 times sine 59.5 over 21.2, right? Which is give you what? 24.6 times sine 59.5 do you think I calculate something wrong again? Because 21, 12, 24 I think I calculate something wrong one more time. Let me see. Okay, I think it's good. So yeah. So I'm gonna put this one over here, 59.5 degree. All right. Okay, then you divide it by 21.2. So 0.99, and you take inverse. 0.999, you take inverse of sine. Give you alpha is, beta is 87.43. Do you think so? I think your answer is kind of weird though. Let me check everything from here one more time. So 21 squared. This is 2 is squared, this is alpha. I think I calculate alpha wrong though. 24a is 21.2. Let me check my 24.6. 12. So 21.2. I hate this, you know. Minus 24.6 square minus 12 square. Okay. Divided by. So this is 2 right here. I think I missed something, right? Divided by 2 times 24.6 times 12. Now we got. Then you take inverse of this. Right. 15076 558,266. Take inverse of cosine 59.5. Yeah, it is. So alpha 59.3. That's alpha. Yeah. So we good. So 59.5. Okay. So 59.5. Apply law of sine. 59.5 over 21.2. Sine beta over 24.6. Right. Sine gamma 21. Okay. So sine beta will be 24.6 times sine of 59.5. Oh my god. 24.6 times sine 59.5 degree divided by 21.2. Okay. So you have over here will be, I do one more time, you know. 59.5 sine times 24.6 divided by 21.2. Sorry, 0.9998. Then you take xi 88.9. 88.89. So beta is 88.89. Okay. And now you can get gamma easily. Okay. All right. 24.6. Yeah, please go ahead and check it one more time because I'm afraid I have careless mistake, but I don't think I checked one time already. Okay, so from here you can get gamma, you take 180 minus 88.89 minus 59.5 degree, and you got gamma over here. Okay, so the strategy is like that, you know. Please, I want you guys to recalculate it to make sure that I don't have any careless mistake. So again, the law of cosine you can apply for sine and cosine and SSS sine case. When you solve triangle, you have to be flexible. Sometimes you can apply law of sine first. Okay. Sometimes you have to apply law of cosine first. So try to be flexible. Try to see what information they give you so that you can make your own decision. What law you should be using. Okay. All right. So that is all for solving the triangle. Let's do another example when we do application of using law of sine or cosine. Let's do one problem of application. Okay. Let's do one problem application. Let's see. So example 3, application. So I have a tunnel for hydroelectric power. So the tunnel looks like this. Okay, and the tunnel is kind of going through the mountain. Okay, so the mountain like this, kind of like that. Okay, so from the top of the mountain to the left end of the tunnel is 5.32 miles. Okay, and the top here to the right end of the tunnel is 2.63 miles. So this is tunnel, this is mountain. Okay. And the angle created by the side of the mountain and horizontal line is over here is 42.7 degree, and over here is 48.8 degree. Okay. Question A. I ask you what is the length of the tunnel? Okay. Question B. What angle does the tunnel make with horizontal line? With the horizontal. Okay. All right. How are we gonna do this? Of course, we over here we use we can apply law of sine or cosine. It's up to you. Okay, but we're learning law of cosine, so I think we can apply law of cosine. So they ask you for this length. Okay, so I call this L. Okay. Oh, look at that! The mountain is kind of a triangle, right? So they got a sine, we got a sine in order to find the opposite. You just need to find the angle here, and the angle here is very easy. You take 180, right? Minus that. So 180 minus 42.7 minus 48.8 give you 88.5. Now you can apply the law of cosine because you already know sine angle sine. So L equal L square equal to 5.33 square plus 2.623 square minus 2 times 5.32 times 2.63 times cosine of 88.5 degree. Okay. So give you what? I take cosine of that. Cosine of the answer give you 0.86 times 2 times 5.32 times 2.63. So I got over here, that part over here is 6.52. And over here I have 5.32 square plus 2.63 square. Over here I have 35.2193 minus, okay, minus 6.521. I have 28.6983. You have to be careful because you don't want to put everything, everything into calculator because it's easy for you to get mistakes. So I just put part by parts. Then I can take square root. So I have 5.35 miles. Okay, so that's the length of the tunnel. Hopefully everybody got the same. So that is the length of the tunnel. Now I want to find the angle created by the tunnel and the horizontal side, the horizontal line. Alright? So this is the tunnel, the horizontal line is this. Okay, so this is what I asked you. This angle right here. I got the angle alpha. Very easy, guy. Very easy. Okay. So in order to get alpha right, so you see that this and this parallel to each other, right? Okay. It is parallel to this angle, so this angle is the same as the blue one right here. So the blue one over here is 42.7 also because it's an interior alternating angle. I already mentioned this term, I think more than a month ago. This horse is parallel to this, right? So this equal to this because it's transversal line, geometrically. Okay, so this is 42.7, 42.7. So in order to find alpha, you take 42.7, subtract this one, right? Just subtract the red one right here. Okay. So I call the red one is better. Okay. So alpha will be 42.7 minus beta. But the thing that I need to find beta, how should I find beta? Alright, that's pretty easy because now you know this is a triangle and you can apply the law of sine, right? You can do a sine beta over 2.63 equal to sine of 88.5 over L is 5.33, right? Then you can find sine beta easily. 5.33 times sine beta equal to 2.63 times sine of 88.5. Alright. Then you can find sine beta. You take everything into calculator. So 2.63, right, times sine of 88.5 degree. Okay, you divide it by 5.35. Oh, 5. Is that 5.35? Yeah, okay. 5.35, okay. Give you 0.04914, and you take the inverse of that, of course. This beta over here is acute angle, so 0.4914. You take inverse of sine, give you 29.43 degree. Right? 0.4914. Take inverse sine. Yeah. Then you got beta already, and you got you can find alpha will be 42.7 minus 29.43, and it give you what? Minus 42.7 give you 13.26 degree. Alright. Everybody clear? So you see, I told you many times that trigonometry is kind of similar, kind of related to geometry. So you must be able to see, recognize alternating interior, exterior, interior. Okay. So that's all for the lecture today. In the next video, we'll be talking about something new, a concept that's very totally new to you, I think so. But this concept is very important, especially to those who's gonna take physics. Okay, and this is the whole branch of mathematics in the new video. But for the law of sine, law of cosine, we can stop over here. So hopefully you guys can go ahead and do homework. If you guys have any questions, just let me know. Okay, thank you so much, and I'll see you next time. Bye bye.